right. Reciprocal functions. First off, what is a reciprocal?
The opposite.
The opposite?
Switch it up.
The inverse. What is the reciprocal of 2 over 3? Right. How did you get that? Okay. Well, what about if you can't flip it over?
I times it by, I divided it by 1.
Okay, you did 1 divided by it, okay? So 1 divided by 2 over 3 is the same as 3 over 2, okay? So this is the reciprocal of this, okay? Reciprocal. Technically, yes, you are flipping it. If I've got x, the reciprocal of it is 1 over x. Okay, and f of x equaling 1 over x is called the reciprocal function. Yep. All right, now, what happens f of x equaling 1 over x as x gets closer to 0? What happens to our function? It gets big, right? Okay, so the closer that x gets to 0, so for example, let's say it's just 1 over, let me write it like this. Let's say if x is equal to 0.1, then f of x is equal to 1 over 0.1, which is 1 divided by 0.1. Okay, sorry. Sienna. Alright, so when x is 0.01, what's f of x? 100. When it is 0.0001, 10,000. Right, so we can see that as our number on the bottom, as our x value gets closer to 0, our f of x gets larger and larger and larger. Now, these are called limits, okay? And a limit is the value y, which is tending towards but does not reach as x tends towards a certain value. So we're saying as x tends towards the value of 0, yep, our y value, or f of x, tends towards infinity, right, but never actually gets there, okay, because we can get infinitesimally closer and closer and closer to 0. That's just going to keep making our y value just get bigger and bigger and bigger and bigger. Yep, so it gets closer and closer to, but doesn't actually ever reach.
A limit is a value which y is tending towards.
So a limit is the value y, okay, which is tending towards, if I left out something, which is tending towards, yeah, which is tending towards, I guess, a value that does not reach. Okay, so it's y is tending towards a value that does not reach it, as x is tending towards a certain value.
So the limit for the first one is 10.
Yeah. But we wouldn't say that. No. Because so 10 is the value when x is 0.1. The way that we write it, I'll show you now, okay? So the way that we write it, so 4, I'll use a different color. For f of x equaling 1 over x, the first limit is given as, so we say the limit of f of x, which is our 1 over x, yep. And we're saying as x gets closer to what value? 0. Then what does this whole thing equal? Or get to go, what does it tend towards? Infinity, right. Okay, so that's how we would write it.
What do you mean by the first limit?
Because there's going to be more than one. Okay. Now, we are just considering this from, I only looked here as it's getting closer to 0 from the positive side, yeah? Okay, so I need to stipulate that and say we're only looking at 0 from the positive side. Because we could say, what would the limit be as x goes towards 0 from the negative side? Yeah? So if you put a negative value in, getting closer to 0, 1 over a really small negative value gives me a really large negative value.
How would I say, as x tends to 0, the limit?
So you're almost, yeah. So the limit of f of x as x tends towards 0 from the negative side is equal to negative infinity. Is it worth writing that down, yeah? Yes. So the limit of f of x as x tends to 0 from the negative side equals negative infinity. Now we do have, so those are kind of like the first two limits for this. We do have other ones. I'll start off. So the limit of f of x. Can anybody tell me what you think? What's another value that I could make x that would be a limit? Well, we've already done 0. Okay, we've already said as x goes towards 0. There's another value.
1.
Well, if I let x equal 1, it's just going to be 1 over 1. So it's a value, so as it tends towards this particular value, my function is going to tend towards another value. Infinity, right, because what's going to happen as I let x tend towards infinity? What happens to the function? It gets closer and closer to 0, because 1 over a very, 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 very large number makes it equal 0. So I could say that the limit of f of x as x goes towards infinity is equal to 0. And I can also do that from the positive side and also from the negative side. Okay, so it's a little bit strange this, but we'll draw a sketch of 1 over x to see what it looks like, and hopefully that will make things a little bit more clear. Okay, so here is the graph of, actually, what do you think it's going to look like? You might know already. Yes? Okay, is that it?
This one.
No. Yeah, it's like that, yeah. So
What?
It's the
I
actual
did
thing.
exactly what I just did.
you went like
You
this.
just
Exactly.
No, why are they going the same
Okay, so here is our graph of y equals 1 over x, okay?
It's just that it's
And I can see, if I can write on this, let me take a screenshot of it.
Oh my god, we have.
Okay, so here is our graph of y equals 1 over x. And we can see from this that as x, so here's our x's, yes, this is my x-axis. As it goes towards 0 in the positive direction, yep, as we get closer and closer to 0, what happens f of x? It gets closer and closer to infinity, okay? It gets larger and larger and larger, okay? That was the first one that we said, the limit as x tends towards 0 in the positive direction of f of x equals positive infinity. We also said that as x tends towards 0 in the negative direction, so that means coming in this way, the limit of f of x goes towards negative infinity. Is that clear? Clear as mud?
Well, so what I don't get is why that way is the negative way.
Because I'm coming in from the negative direction. These are negative numbers.
Yeah, but then isn't it like, oh, yeah, no, I get it.
This is the curve of f of x equals 1 over x. All right, just to come back to your question, Sienna. If you said, if we want to look at the limit as x tends towards 2, okay? So here's the value of 2. If I want to look at it coming from the positive direction, I can see that my curve, as it gets closer and closer to 2, it's going to end up actually equaling it, yeah? Same as if I'm coming at it from the negative direction. So the limit would just be 1 over 2, because that's what it would actually equal. Whereas with these ones, it doesn't actually ever equal infinity. It doesn't ever actually equal negative infinity.
So you can't just make up limits.
No. No. Limits are not very nice things, actually, to be fair. We also said the other two were the limit. Now, these are ones that students tend to not like so much. Of f of x as x goes towards positive infinity. So as I'm looking at this, my x-axis is tending towards positive infinity the more I move in this direction, yes? Yep, it's way, way out there. I can see that my f of x is getting closer and closer to 0. Okay, it's getting closer and closer to the axis, yep?
Oh, yeah.
Yep, same with on this side. The limit, as x goes towards negative infinity of f of x goes towards 0 as well. Yeah, because, okay. Sienna.
Yeah.
The limit as x goes towards positive 0 equaling this, and as it goes towards negative f of x equals 9. Represented by a vertical line. And again called an asymptote. So if I was going to do a sketch of this, it's more difficult whenever your asymptotes are on the axis, but when they're not, it becomes more clear. And then I would put in a couple of sketched dotted lines. Can't even see it. Okay, so you want to be able to, it will become more clear whenever we do these with when they're not on the axis, but you want to have your dotted line drawn in for your asymptotes, okay? Also, when you're drawing these, you never want to have your graph touching the asymptote, okay? You will be expected to draw these, so your graph must never touch asymptotes. If it does, you lose marks, okay? Even if it's by mistake. Your graph, your your graph must also never look like it's going to come back up again either, okay? It has to be getting closer to your asymptotes, but never touching, okay? All good? What can you tell me about the inverse of a reciprocal function like 1 over x? Yeah, like, what can you tell me about it? You should be able to, you should know something about it. No.
X minus 1.
No.
X to the power of 1.
Which is?
Oh, wait.
1 over
X.
x.
Oh.
Right, so what can you tell me then? What do we call it?
An exponential
No. I've got,
Disgusting.
yes, I am. I ain't even got to exponentials yet.
But it's an exponent.
F of x is 1 over x. What's the inverse of 1 over x? How do you work out the inverse?
Oh my gosh.
It's just 1 over x.
Thank you, Sam.
I was solving in my head, I'm like, it's just the same thing. But
And what do we call that?
Wait, I forgot how to do that.
Me too.
They're the same. They're the. Wait, let me. Wait.
Symmetrical function.
No. I know what you're talking
What
about.
are we even talking about?
Like when you reciprocate it and the
Just need to do more
Wait, what's it?
review. This is a self-inverse.
When did we learn that?
we were doing
When we did functions.
That was the best.
Oh,
No.
that was when me and Bella weren't here.
What else do you know about functions and inverse functions whenever I draw them? What do I know about functions and their inverse whenever I sketch them, like the graph of them?
they're like a reflection.
although y equals x.
On y equals x.
Oh, and that goes up to 3 y.
Thank you again, Sam. Okay, so if I was to draw y equals x, okay, it's being reflected on y equals x, okay? These are all things that you gotta remember. Okay, we didn't do this that long ago. Okay, let's leave it there for now. Let's have a look at page 191, okay? I want you to have a look at investigation 3. And then these will get more tricky, okay? Because at the minute we're just looking at some number over x. We're going to be making it a lot more complicated than that, okay? But 191.